Welcome guys to my YouTube channel. Guys, we now solve this problem. I read the question first. If alpha, beta are the roots of the quadratic equation ax squared plus bx plus c is equals to 0, obtain the equation whose roots are 1 all over cube 3, that is alpha raised to 3, and 1 over beta raised to 3 in form of A, B, and C. So guys, we have a problem here we need to solve. And guys, we are told that alpha and beta are the roots of this quadratic equation. And so guys, we need now to find the equation whose roots is alpha and beta, and then we equate that equation with this equation. And this is what we are going to do, guys. Here is the equation first. This is the equation we are given. Guys, we can come and divide every term by a. And we divide, we get that. From there, guys, we come now and look for the equation whose roots are beta and alpha. And that equation is given by this. Remember that, guys, if we have a root, we have alpha and we have beta as our roots. If we were to go backward, guys, to the equation, this is what exactly we shall find. Just as we usually say, any number, what number can we, if we add, we get this. If we multiply, we get this. So as you can see, we are adding this. And this one is alpha and beta. If we multiply, we get that. So guys, we are saying, when we have two roots, alpha and beta, this is the equation that is formed. Because as we usually say, numbers that you add or numbers you multiply. And so therefore, guys, we continue. Continuing, guys, we come now to this. So guys, if we compare these two equations, this equation and this equation brought about by alpha and beta, it goes without saying, guys, that minus alpha plus beta then should be equal to A. Because remember this, that guys, these two equations are supposed to be similar. So whatever is in front of x should be the same as whatever is in front or behind x. And this one is negative alpha plus beta. And as you can see, the product, alpha plus beta, then should be equal to C all over A. Guys, I can give you assignment. Find the equation whose roots are alpha and beta. And guys, you are going to find something like that. And so therefore, guys, we continue. After that, guys, we come to this other, what we are now being asked. We are now asked about an equation whose roots are 1 all over alpha cubed and then 1 all over beta cubed. So, guys, the same way we have done this first equation, alpha plus beta, this is now going to be 1 all over alpha cubed plus 1 all over beta cubed. And this is now going to be 1 over alpha cubed multiplied by beta cubed. So the same case, guys, if you look for equation whose roots are this, guys, we shall find this as the equation. Guys, I also give you an assignment to go and find equation whose roots are 1 all over alpha, 1 all over alpha cubed, and 1 all over beta cubed. Guys, you shall find this equation. And therefore, guys, as you can see, already we have our alpha plus beta as b equals to a, and alpha beta as c equals to a. So, guys, we want to transform this equation in terms of a, b, and c. And so let's look and see what we can do. Guys, when we come at this position, before we come at this position, this term you see here can be changed to alpha cubed, beta cubed, and then the numerator going to be beta cubed plus alpha cubed. So guys, these are similar. This and this is supposed to be the same. And so guys, we continue. So we have an equation here. This one is from our first, is actually from this. Guys, when we come and cube this one, this is going to be also be cubed. Only difference, guys, we have brought this negative, we have put it this side. But now when we cube this one, it comes to this. Guys, remember our quest is to come and replace this alpha cubed, beta cubed, alpha cubed, beta cubed with A, B, and C. And so therefore, guys, the first thing we can find is this. Remember, when we look for this, guys, we shall have something like this in this equation. And this can be solved by what we call binomial expansion. And this is what we have, guys. So we have alpha plus beta, you cube that, this is what you get using binomial expansion. And so this is now equal to negative b all over a into bracket cubed. Guys, we can now factor out the alpha cubed and beta cubed, as you can see them in this position. So we can actually we can leave this one alone now, that it's still there, but we can leave it now. Now we deal with this, because already we have this alpha plus beta into bracket cubed is equals the same as negative b all over a cubed. And so therefore, guys, so that to be left with this and that, we are just going to move all the other figures this other side. That is 3 alpha squared beta plus 3 alpha plus alpha beta squared on this other side. And this is now what, guys, we have. As you can see now, we have moved all the values on the other side. We are left with that. And this comes now to minus b all over a into bracket cubed minus, I have put this minus, but remember, guys, these two are minuses, and so I have a bracket right there. So that now, guys, this is going to be, sorry guys, it's actually already there. That is already there because here we have 3. So we have a minus here. This is a bracket. Guys, this is just one bracket. So we have 3 alpha squared b beta plus 3 alpha beta squared. That's what we have, guys. Now from there, guys, as you can see already now, we have alpha cubed, beta cubed, expressed as that. Guys, what now we need to do is to come at this position. Already we can factor out now 3 alpha beta, and we are left with that. Being left with alpha plus beta, we can replace that with b all over a. And so therefore, guys, we have b all over a. And remember our negative, this negative we can move here. Then we are left with alpha and beta. We can use this alpha beta is equals to c over a. Of course, guys, we had that formula, which is right here. And so when we replace that, guys, we are going to be left with such an equation. Going back to our equation, guys, this is what we are going to have finally. But now our equation is this. So, guys, we can now replace that. We can also replace this. This one is replaced by alpha beta. If you cube that, you also cube that. And the same case here, we can do that. And this is what now we are left with, guys. After we have replaced all the alphas, all the betas, guys, we are left with that one. Guys, you can try to simplify that and see what you get. But finally, guys, this is our solution. We have that, and the final solution is that. So, guys, this is what we have. as our solution. Thank you for listening to me. Bye bye.